All right, today we're going to pull back the curtain on something you probably use every single day, voice assistants. We're going to break down how they're built right from the ground up, and we're going to do it all in about 5 minutes. So, you ready? Let's dive in.
I mean, really think about it. You talk to your phone, your smart speaker, maybe even your car, and somehow it just gets it. You ask for directions, you tell it to play your favorite song, and poof, it responds. But how? How does that piece of tech actually listen to you and figure out what on earth you're saying?
Well, the secret sauce behind all of this is something called voice recognition. And really, all it is the technology that takes the sound of your voice and turns it into text that a computer can actually read. That's it. It's the essential bridge connecting our world to the digital one.
So let's get into the nitty-gritty of this so-called magic. We're going to break down exactly how your voice makes that journey from just a sound in the air to actual words on a screen.
You know, the easiest way to picture this whole thing is like an assembly line for sound. Seriously, your voice is the raw material that gets fed in one end, and then it goes through a bunch of very specific, very organized steps. And what comes out the other side? A finished product, text. It's a beautifully engineered system, and we're about to walk through it.
Okay, so like any good construction project, you need the right tools. And for our digital assembly line, our toolkit is going to be built using Python. So let's take a look at the essential pieces we need to get this thing running.
So, first up, you've got Python itself. That's kind of like the factory floor, the foundation for everything. Then, you need the speech recognition library. This is the star player, the main machine that does the heavy lifting of translation. But how do we get the sound to the machine? That's where PyAudio comes in. Think of it as the digital ear, the microphone for our code. And finally, we have NumPy, which is awesome at crunching all the numbers that sound is made of. It keeps everything organized.
All right, so we've got our tools laid out. Now let's see how they all work together. What does our little sound assembly line actually look like in action?
So here's the workflow. It all kicks off with step 1, audio input. This is where our digital ear, PyAudio, grabs your voice. Next up, and this is super important, is step 2, noise reduction. The system has to clean things up, right? It filters out stuff like a car horn or the air conditioner to get a nice, clear signal. Then, in step 3, the brain of the operation, the recognition model, gets to work. It analyzes that clean sound, breaks it down into phonetic bits, and matches those patterns to words. And boom, step 4, text output. The words you spoke just appear on the screen.
Okay, so that basic assembly line, it works. It's pretty good for simple stuff, but if you want the kind of mind-blowing accuracy you get from Siri or Alexa, you gotta give it a supercharge. And that's where AI comes in.
And this right here shows you the massive difference. On one side, you've got standard recognition. It follows a fixed set of rules, so yeah, it's gonna struggle in a noisy room or with a thick accent. But on the other side, you've got a deep learning AI. This is a total game changer. It uses what are called neural networks, which are basically designed to work like a human brain. It learns from huge amounts of data, so it doesn't just follow rules, it adapts and gets smarter over time.
All right, so we've kind of built our voice assistant, at least in theory. But where is this tech actually being used out in the real world? And what are the big roadblocks that people are still trying to figure out?
Oh man, the applications are literally everywhere. Of course, you have your virtual assistants like Siri and Alexa, but it's also the engine behind those awesome services that automatically type out notes from your meetings. It's what lets you control your smart home or your car with just your voice. And maybe most importantly, it's a huge deal for accessibility, giving people with disabilities powerful new ways to interact with the world around them.
But for all this amazing power, this tech is far from perfect. There are still some pretty big hurdles that developers are busting their butts to try and get over.
I mean, background noise is still a huge problem. It can totally confuse even the best systems. All the different accents and dialects out there, yeah, that's another massive challenge for accuracy. Plus, doing all this processing instantly takes a ton of computational horsepower. And then, of course, there's the big one, privacy. What happens to our voice data? Where does it go? That's a conversation we're all still having.
So, there you have it. We've gone from a simple sound wave to this incredibly complex AI-powered system that's changing just about everything. We've seen the tools, the workflow, and the big challenges ahead. And look, this technology is only going to get better, more seamless, and more a part of our daily lives. So that just leaves one last, really exciting question. What are we going to build with it next?